like to welcome everybody tonight to our session. I'm Joel Kirshen. I'm the president of the St. Louis chapter of CSI. Tonight we've got an interesting session on technology, advances in technology with elevators, up to and including some touchless technologies. I do want to welcome Stephanie tonight, who's going to be our presenter tonight. So thanks, everybody. Enjoy the session. Stephanie, all yours.
All right, well, thank you. Just a little introduction. My name is Stephanie McColgan. I am with Kone Elevator. Here in St. Louis is my main territory. And so today we are going to do a little bit of an elevator AIA presentation. I don't know how many people have seen this presentation at your firms. If you're interested in having me come in or doing a virtual presentation for your firm, that is also something we are offering right now. We can cater in lunch to your office if there's people in your office, and then I can do it virtually, or I can come in and do it however you prefer. So this is just a little video to start us off. And there's no sound, it's just music. So anyways, Kone is a global leader in elevator and escalator industry. We're here to make cities a better place to live. Kone was founded in Finland in 1910. We have over 57,000 employees and over 250,000 customers. Anyway, so we are looking for smooth people flow in different types of buildings, and we basically cover every type of building out there, from hotels, medical, public transportation to residential. We'll see how much office we're doing in the near future. So basically what we're able to offer for your project is planning, expert planning, easy to use online design tools. We have everything from designing your elevator cab for your client to just getting on there and getting Revit models for any type of elevator that you're designing for the most part. And then from there, we go from design to installation, where we try to, I'm going to minimize this so I can see, providing a scaffoldless installation methodology. We're very big on safety to maximize our site safety, and then eco-efficient installation. And then from there, it goes to your owners, and we are focused on handover and maintaining the elevators and making sure that Kone Care maintenance solutions are provided to your owner and that they have minimal downtime with their elevator if anything needs to get fixed. So this is our elevator presentation and what the architect should know. We will start with a history lesson and then go to some traffic planning. How big is that cab? Basically understanding the size and the shape of the cab that you're specifying. We'll cover a little bit of building integration, some code reminders, and some movie myths that we can bust some of the rumors you hear about elevators. So we will start with our little history lesson. So basically the very first elevator invention was an ascending platform, and that was back in 1854. And there was not tremendous advancements in elevator technology until probably the 1990s, when the first machine roomless elevator was brought to the market. And now we are able to use carbon fiber cables, turnstiles to call elevators and cell phones to call elevators, which I think you will be seeing more of as future trends move forward. So basically, if we look at elevator technology in the past, there was two types of elevators. You had hydraulic elevator, which served your low-rise market, and then traction elevator served your mid to high-rise market. So we were going to look a little bit further in detail on what makes these two applications move the elevators. So with the hydraulic elevator, basically, as you can see here, I don't know if the arrow is showing or not, but there is a cylinder that goes into the ground. So if you have a 4 or 5 stop elevator, we were drilling down to the ground as far as you're going up plus. And so the way it would work is you had this big tank of oil and a controller on the front of it, and a passenger would come up and activate the hull station. That would then tell the controller, which we refer to an elevator controller, kind of you think of it as the brains of your elevator. And then from there, it would tell the pump unit to start pumping oil out of the big hydraulic pump unit that's sitting there. The oil would pump down into a oil line that then went down into a cylinder. And in that cylinder was a piston. So the oil would push the piston up to make the elevator go up, and the oil would run back into the tank to make the elevator go down. And that's essentially how you got the elevator moving in an up and down motion. If it is a dual hydraulic cylinder, so in this case, maybe for a 2, sometimes for a 3-stop elevator, they will do that. And that means that cylinder that's underground here would be inside the elevator hoistway on both sides of the elevator, kind of by your rails. So one of the things about the underground hydraulic piston that people don't realize, but owners will know someday, is that anything underground is not covered by a maintenance contract. So if something's underground and we can't visibly see it, the elevator manufacturer is not going to provide any type of warranty service for that piece of equipment. And the problem that happens is eventually these cylinders, they can either leak or they need repacked, and that can be a capital expenditure for your owner at $40,000 to $50,000 they weren't expecting, because you don't know what's going on underground. They have no way of knowing when it's going to go out. So that kind of made us try to get away from that type of technology. Part of the other thing with this is in order to push that elevator oil through the little pipelines and then make that piston go up, you also need a lot of energy to get this piece of equipment into motion. So you're probably talking about 40 to 50 horsepower in order to get that thing moving, which isn't a big deal. Maybe, you know, if for a small building, but then if you have to hook it up to an emergency power within your building, you need a really big generator in order to get the elevator on emergency power. So the other type of elevator that was the more expensive type of elevator, I guess at the time, was a traction elevator. And this type of technology essentially is using electricity to get your elevator into motion, and a pulley system. So basically you have a cab and then there's a counterweight, and it's a pulley system between the two. The machine, which would always be in an elevator penthouse, would have to be craned into the building after the roof was on, basically, and then the contractor would crane that machine up into a penthouse. That machine then would sit on a structural slab or machine beams at the top of that hoistway, which obviously added a lot of structural requirements to the top of that building. But to get this elevator into motion, the passenger would push a button, your controller activates, your motor rotates, and then your elevator ascends or descends opposite of the counterweight. And that's basically how we got that elevator going into motion. But this also provided with the faster speed, smoother ride. You get a lot better quality elevator with this type of technology. So luckily, finally in the 1990s, the machine room-less elevator, and I did not name that one, was invented. And basically what they did is they took that large AC gearless machine out of the elevator penthouse, and it was designed to fit, and I call it like a little pancake machine at the top of the elevator hoistway. So you get the same technology using a permanent magnet synchronous motor without having the big machine at the top of your hoistway. Now this machine is mounted in the overhead for the elevator. All the reactions are then transferred down to the pit floor. So there's no big structural requirements to support that machine at the top of your hoistway. Basically 2 bracket attachments for however your structural engineer is designing your steel is all you should need. Still using that counterbalance system to make your elevator go into motion. This machine for like a 2,500 pound car is going to run on approximately 7 horsepower. A 5,000 pound machine will still be under 20 horsepower. So still significantly less than what that hydraulic elevator was requiring for power. And if you have an elevator that's going up and down like this one, that's a lot of savings for your owner in terms of electricity cost. So some of the benefits of the traction elevator compared to the hydraulic elevators that you can get higher rises, faster elevator speeds, and an hydraulic elevator going at 150 feet per minute is actually slower than the traction because the oil has to push up through the pipes in order to get up to 150 feet per minute, where traction elevators are going to take off and get up to speed right away. So we're not relying on any type of oil. You also don't need that sump pump with an oil separator because there is no oil with a traction elevator. You get a better ride quality. I don't know if you've ever been on an elevator and you can hear, you walk into a hotel, you hear the pump unit start revving up, the elevator comes down to the floor, you might get a little hydraulic fumes, and then you can hear that pump unit revving up to get you up to your floor. And sometimes you can even see where the elevator's leveling out so that the 2 sills, the car sill and the entrance sill meet up. So those are some of the things that identify if you are on a hydraulic elevator. So like I said, with the traction elevator, you're getting that AC gearless machine, which it used to only be available in mid to high rise buildings. This machine is 93% efficient compared to 65% efficient with a hydraulic elevator. So like I said, in energy savings, you're talking a 7 horsepower versus a 40. So basically, if we look at this, it's obvious what they're getting at is that the machine-less elevator is the best of both things offered in elevator technology. So some of the technological advances we are seeing within our industry, which I said took a really long time for these things to come about. One is the destination control. In the St. Louis area, I think the most prestigious destination control we have is at Centene Plaza. The whole urban campus, for the most part, has this technology in the main buildings. So basically what this allows is conventional elevator control is what this picture here is on the left. And basically you have all your passengers waiting in a lobby trying to get on an elevator. And basically you push an up or down button depending on where you want to go. And let's say you get into the elevator and you need to go to floor 15. So you get on the elevator along with everybody else who is going to floor 2, going to floor 20, going to floor 30 maybe. And everybody gets on the same elevator and some little kid is in the elevator and then they hit every stop in the button and now you're stopping at every floor. So what the destination control is going to do is group people by destination instead of getting in an elevator and pushing a button. So basically a passenger walks up, we'll have a little video that demonstrates this next, but the passenger walks up and they hit what we call a destination operating panel. You punch in what floor you're going to go to, and then it's going to group passengers by destination. So in theory, let's say it tells you to stand by elevator A, that elevator may be stopping at 5, 7, and 9. And maybe yellow elevator D down here is maybe stopping at 18, 20, and 25. But it's keeping elevators from basically going up and down an elevator hoistway all day long, just chasing each other. And it also uses artificial intelligence to learn traffic patterns. So let's say, at 3 o'clock, whole bunch of tenants need to come down because that's when their dismissal time is in the building, the elevators will know that it needs probably 3 elevators waiting there to start bringing those people down to their destination. So it's saving energy, having not having elevators going up and down the hoistways all the time. And it decreases the amount of time that a passenger is going to wait to get to their destination. Now, if you add turnstiles to this, like they did over at Centene, the way that works is a passenger walks in, they have a home floor, so you swipe your badge. The turnstile tells you to go stand by elevator G. You walk up to your elevator, you never touch a button, you get on the elevator, and it takes you to your floor. Once you get in the cab, it says, okay, you know, we're going to floor 10. And so you know just by looking at the indicator inside the elevator that it's stopping at your floor. So it's pretty cool technology in order to provide a touchless solution. And at this point, getting people to their destinations in a more timely manner. So this is a video that kind of shows how this works. Can you see that? So he's selecting, my floor is 5, tells him to stand by elevator A. This is if you have card readers and you don't have a predetermined floor, but you can just type in what floor you want to go to and you either have access or you do not. So that is destination control. So that's one of the touchless solutions that are now available. Are you able to see this one too? So this is another option. Yeah. If you had destination dispatch that is being offered, where you can actually do, instead of a DOP outside the elevator, certain people within the building can have an app on their cell phone for Kone Call, and they are able to call the destination dispatch elevator from their cell phone. So that also will reduce some of the waiting times, and you have to be within so many feet of an elevator, obviously, in order to get it to work, because if you're too far away and call an elevator, it really doesn't benefit anybody. Another thing that we are now offering are carbon fiber cables, but this is basically just for really tall buildings that so that they can be built taller, use less energy, they last longer, and they don't sway as much. So far in St. Louis, we haven't been able to provide one of those, so we'll move on to the next thing. So a regenerative drive is standard on a lot of the machine roomless elevators we provide now, if the travel's not too great. So basically when a heavy load travels down, the motor prevents the car from falling into an uncontrolled manner, and the braking energy is converted into electricity. So in other words, the motor acts as a generator, supplying electricity back into the building grid. So the same thing also occurs when the empty car travels up. So we're trying to find ways to have elevators get to net zero, hopefully sometime in the future, to not use as much energy within buildings. So one of the other things that we have now to complement the machine roomless elevator is an integrated control solution. And this is available on most elevators, but something you need to verify during design if it's offered for the product that you're specifying. So basically with this, within your entrance frame at your top landing, that controller just slides in and out of the entrance frame so you don't have to build a controller closet. Now there's minimum dimensions on how big that frame needs to be, and that kind of depends on what capacity of elevator you are specifying for your project. But in most cases, it's about 8.627 inches is how wide that frame needs to be at a minimum in order for that controller to fit behind it. But then because your machine is already in your elevator hoistway, which we consider to be kind of the heart of your elevator, and now the brains is in the entrance frame, we have a truly elevator solution that does not require any additional rooms. to be built for your owner, which is a big deal, especially if you're trying to free up space at your first level for retail space or any type of leasable space that could be for an advantageous thing for your client to be able to lease that instead of building elevator machine rooms or control closets. Some things to consider with this is, obviously your local codes, speed and capacity. I know this would not be available like at 350 feet per minute or 500 feet per minute yet. Hoist weight conditioning. One thing I always like to point out when designing an elevator, in most cases, proper ventilation at the top of your hoistway will be sufficient for making all that electrical equipment run properly. Elevator controllers and machines need to be maintained between 41 and 104 degrees, 95% non-condensing. So if you were designing a parking garage or something where I guess the sun's going to shine on there and that area could get significantly hot or cold, you would want to have your HVAC person look at how to condition that space to maintain those operational parameters. Basically, what will happen with an elevator is if it gets too hot, it's going to be like your cell phone and it's just going to shut down until it cools off. So, and that's not something we want, obviously, in a building, is to have the elevator shut down and not be able to use it. One of the other things that Kone is also offering now is 24/7 connected services. And this basically is using IBM Watson to troubleshoot elevators and know, talking to the controller, if something's going wrong before the owner will know. So there's certain fault codes and stuff you can get in an elevator controller that if you're connected to Kone 24/7, that the owner is going to be aware of before, the IBM Watson and Service Center will know before the owner knows, so we can dispatch a mechanic to take a look at it. One of the other things I wanted to show you before we get off this is to look at just a little video about something else we have called Kone Call. Basically, we've generated an app and anybody can use it to call an elevator from your cell phone. So this does not require DCS. This is just strictly any elevator and anybody can use this. So you don't need to touch any buttons to get to your destination using the app. Okay, so now we're going to look at a little bit of traffic planning. And Kone will offer traffic planning for your project. Generally speaking, you would want multiple elevators and mid to high rise buildings to look at this. And we can look at different building types, office, hotel, residential. And based on that, there's an industry standard for acceptable intervals of waiting times. And the handling, and that we look at the handling capacity of your building to see how many people we need to move within a specified time period. So some of the information we would need to do this is the number of floors within your building, specifically, the floor to floor height, how many entry floors are people, and like in this picture, coming in kind of down at this bottom level and they're walking in, is there parking at 3 levels below? We need to know how many levels people are entering into the building. And then as you go further up, we need to know how many people are occupying the other upper floors to know what an acceptable wait time would be. So how fast and how big do your elevators need to be for that building? So what we're looking for then, besides the number of floors, is the population per floor. Industry standard would be 1.5 to 1.9 people per guest room at a hotel. Residential says 2 people per master bedroom and then 1 person per additional bedroom. And office, we look at how many square feet per person are occupying that area, because obviously if you have a call center with a bunch of cubicles, we're moving a lot more people to an upper floor than if there's a bunch of offices on that level. The other thing we need to look at is what are the floor-to-floor heights of the building. So the greater the floor-to-floor height, the longer that's going to take your passenger to get to their destination. So based on this information, we can generate a report and it's kind of based on class of service and what the industry standard is for that type of building. And the report will determine if the number of elevators and speed is excellent, good, or satisfactory. So what we're measuring with these reports is the relative handling capacity, which is the percentage of building population moved in 5 minutes. And then we also look at the interval, which is the average time between floors leaving from the main floor for a passenger to get to their destination. Okay, this is a service-shaped elevator. A lot of architects like to call it a freight, but I always try and explain that a true freight elevator has biparting freight doors. A service-shaped elevator is similar to this one to move either gurneys, or like if you have a loading material and you want to move, you know, pallets of paper or whatever, that's what service-shaped elevators are generally used for. So then we can also look at a general planning guide. So every elevator manufacturer has a planning guide similar to this one. Passenger elevators are generally 2,000 pounds to 4,000 pounds. Service elevators are usually 4,000 to 5,000 pounds. They're both offered with the front and rear option. But as you can see, if you look over to the right, the main thing that changes between an elevator capacity, like if you're looking at a 2,500 versus a 3,500, the width of your elevator stays pretty consistent. It's mainly the depth of your elevator that's changing. And then when you get to service elevators, that's when you can get the larger doors. Like a 5,000 pound car can have a 4'6" door or a 4-foot door. And then the doors can get taller as your cab gets taller. So we offer, let's say, an 8-foot cab or a 10-foot cab, and then you could have like a 9-foot door. One thing to also mention is Kone offers a 2,500 pound IBC elevator, and this is basically an elevator that will accommodate a smaller elevator that will accommodate a gurney with a side opening door. One thing unique to our area that I feel like a lot of other areas aren't dealing as much is this whole seismic additional dimensions that we have to add to our hoistway width and depth. And basically the way it is working right now is that if your elevator, you talk to your structural engineer, and if you're in a seismic design category C with a component importance factor of 1.0, you will not need seismic provisions for your elevator. If you are in a C with a 1.5 component importance factor or a category D, you do need to add these seismic provisions. So just something to keep in mind when you're designing. And then obviously when we look at stretcher accommodations over here to the right, the 2,500 pound IBC with the side opening door will accommodate a stretcher, and then a 3,500 pound or greater, 3,500 pound with they're all side opening doors except for this 4,000 pound here. They will all accommodate a stretcher. Okay, so now we're going to look at just some building integrations for when you're designing your elevator hoistways, some things to look at and take into consideration. One is we get a lot of questions about what is my overhead. Overhead is measured from the top of slab of your last landing to the underside of your hoist beam. And I think that's something that gets confused a lot. So the bottom of that hoist beam will be your clear overhead. Your total overhead would be that hoist beam, like Kone provides all of our hoist beams with our elevators, and that's an 8-inch beam. Now, one thing we're offering with our low rise is a movable hoist beam. So if you have something 4 floors and below and you're using our Mono 500 product, we're now making it so that hoist beam can be moved to the back of the hoistway, therefore reducing the amount of overhead required for that elevator. So that's something that's kind of nice. And then what is the pit? Basically, that's measured from the bottom of your pit floor to your first landing. Another thing we can look at is hoistway tolerances. Obviously, we need hoistways that are plumb and in line so that our elevator guide rails stay straight. So we basically say plus 1 inch minus 0 so that your elevator is not zigzagging in and out. So if you have a CMU hoistway, basically, I know we can say tell the mason to build a perfectly straight hoistway, right? So in most cases, we just say if you want to build it an inch bigger, that allows for accommodating some of that. With the CMU hoistway, the elevator manufacturer will provide inserts, so there is a tiny bit of play, to adjusting the bracket attachment points, the guide rail brackets to those inserts if needed, but we don't have more than a couple inches to extend those. So you have to be real careful when we're designing, making sure that wherever the tube steel or inserts are, they're not too far away from the bracket itself so that it can extend that far. So speaking of bracket attachment points, with the machine roomless elevator, there are 3 bracket attachment points. So the one here on the left, that one will accommodate your machine and your counterweight. The one on the back, right behind it, still on the sidewall, that is one for your counterweight. And then we have one on the opposite side of the car for the guide rails. So basically, this is what a drywall hoistway would look like. So it kind of shows, like, one of the important things when you're building a drywall hoistway is if you provide tube steel or weld plates for a guide rail bracket attachment, please make sure that they are not covered with drywall so that we can weld directly to it. And this is just kind of showing what the top of your hoistway would look like with the drywall. So one thing when you are designing an elevator hoistway, because every elevator manufacturer kind of has a different version of a machine-roomless technology, kind of make sure, does the building need to be dried in prior to the elevator installation? The picture in the middle shows kind of a elevator cassette. So the machine is mounted up in the overhead and still needs some support in order to support at the top of the hoistway for basically the reactions and everything to hold it up there. So is any additional steel required by others? Are there any beam pockets required? Who installs or removes any temporary structures? Because some elevators require a temporary structure. So a lot of things to take in consideration when you're designing that. From our standpoint, the elevator hoist beam that's provided needs to stay in the elevator hoistway, and this is for future maintenance. I get a lot of questions, I feel like, that say, can't we just get rid of that hoist beam after installation? And Kone in particular is saying, no, we don't want that beam gone, because in the future, if there was a maintenance issue with the elevator, we need that in order to hang the elevator cap from it and do maintenance on the elevator. So we want to keep those hoist beams up there. Another thing that we like to emphasize is that there are rough openings required to get the elevator into the hoistway and then to kind of frame around the elevator when we put our frames in. Basically, rule of thumb is at the first landing where we unload the elevator equipment, we want that wall completely left open because we are bringing in an 8-foot elevator cab at a minimum and building that inside the hoistway. So we'll start with a platform, build a cab. There's a guide rail on top of that cab. And from there, we use a tie rack on that utilizing that hoist beam. And our mechanics stand on top of the cab and then build the elevator the rest of the way up. From there, the elevator frames would be set, and then we fill in around those frames. So that's why we need that. And if it's an integrated controller, like the controller and the entrance frame, we need 2 feet above that door frame in order to connect all the equipment between that machine and the controller. So we need quite a bit of space on the bottom and the top landing. Your intermediate floors, we usually say 8 inches on each side of the jamb will give us enough room to kind of align that car platform with that entrance frame and adjust it as needed if we needed to move it a little to the left or right, depending on how the building is designed or built, I should say. So a few more things you want to look at is, are there any requirements for stretchers with your local code jurisdictions? A lot of times I think it's above 4 stories above grade or 5 stories above grade before you're going to need to accommodate a stretcher, but more and more, I feel like more local jurisdictions are requiring that. So we need to make sure that we are designing it appropriately. Are there any emergency lowering requirements? So elevators can come with 2 types of emergency features. One would be an emergency battery device, and the other is emergency power provisions. Obviously, that just connects the elevator to the emergency power generator within the building. And the other one is optional for emergency battery device in order to, in the event of emergency power or a power failure within the building, it will either bring the elevator to the top or bottom landing and let the passengers off. However, with that feature, you cannot use the elevator like you can if it is on a generator. Kone provides all the pit ladders with our machine-roomless elevators just because of the type design of all of our equipment. It's just easier for us to provide the pit ladders, so it's always included with our proposals. And then also, are there any local code requirements within the area that you're designing? Emergency communication is becoming a new thing, kind of an interesting new feature that they're coming out with to comply with 2018 IDC and the new elevator codes that are coming out in the near future. So one of the new things that required by 2018 IDC would be a car opening panel that features a touch screen display, as you can see here, and also a camera within that car opening panel. So it will no longer just be an emergency ADA phone that we're used to. This is a little bit more technologically advanced, and it allows a passenger, if they push a button for help, to either text. If you were to be deaf, you can text the agent on the other line what's going on within the elevator, or with a camera, they can look and see if somebody pushed that emergency button and let's say they passed out in the car. So there's different options for people to be able to communicate with help if they need it. So this also requires basically that the elevator be connected to a service center with the elevator manufacturer so that they are 24 hours a day able to use these devices if needed to get help within the elevator. So that's something new that I think everybody will be seeing soon as it's adopted by local jurisdictions. Okay, so now we are down to busting myths from the movies. So factor myth, elevators are held up by one rope and will fall if it is cut. I think we see this with maybe Tom Cruise in Mission Impossible, not real sure. Obviously that is not true. There are, if it's traditional steel cables, you have 4 to 10 steel cables within the elevator that keep them from falling. And also, can an elevator free fall several floors before stopping? There are several safety mechanisms within an elevator. One is this governor. It also keeps an elevator from ascending or descending in an uncontrolled manner. So factor myth, if an elevator gets stuck between floors, there's danger of oxygen running out of the car. Again, that is not true. There is a fan within every elevator, and the elevator hoistways need to be properly ventilated, so that would not be an issue. Another one would be you can escape from inside an elevator car into the shaft through an emergency exit hatch in the ceiling. This one, as they say, is not true, but it is semi-true because there is an emergency hatch at the top of your elevator car. However, a mechanic needs to be on top of the car to unbolt it, and then the ceiling would have to be dropped in order for you to exit the elevator. So it's kind of true, kind of false, but you would not be able to climb out if you wanted to. Pushing the call button multiple times will make the elevator arrive faster. Contrary to popular belief, that is not true. And our final one is that the door open, door close buttons actually hold the door open and closes it faster. That one is true. If you see somebody coming, you don't want them in the elevator, you can hit door close and it will close it on them. So basically that is what I have for today. If anybody has any further questions, feel free to contact me. I'm sure, I don't know if it's Steve or Hank, will be sharing my email address with everybody. And at this point, I guess we will open it up for questions.
Go ahead.
Oh, I was just going to say, I really got to challenge the whole notion that hitting the floor button a lot makes the elevator move faster. I totally think that works. Not buying it.
I really don't want to, bust that for everybody, but.
But what percentage of the market now is the MRL type elevator?
Percentage wise?
Yeah, roughly.
Well, I mean, basically, if it's not 2 or 3 stops, almost everything is.
Mm-hmm.
I don't even know if anybody's manufacturing the in-ground hydraulic elevator anymore. It's all switched because the machine room elevator is cheaper or more cost effective at this point than a traditional hydraulic. I don't honestly know the exact stats on that. But I would say, a good percentage of, I mean, we don't even sell a hydraulic anymore, so that's hard for me to answer. We stopped selling them. The last one we did was the Meridian, and that would have been in 2009.
On those machine roomless elevators, is the control cabinets that is in the front wall of the top landing. Is that the typical location for those control cabinets, or is that an optional?
Well, that would be your most cost effective. So the way that it works is that controller can be moved to a room or a closet within 140 feet of wire run from that machine. But if you think of, if that machine is the heart of your elevator and your controllers, your brains, you kind of want to keep those as close together as you can, because once you start moving them apart, basically what we're doing is we're running wires through ceilings over and down to wherever the control room is. So then you're adding labor to it, and it just increases the cost of the elevator itself. So we try and keep it at that, but it's not always feasible with everybody's design. So we can move it within 140 feet of wire run.
All right, as a follow-up to that, is the access strictly in the jamb, or do you need access to the face of the wall there too?
No, so the front of that wall, it's strictly in the jamb, and it pulls out like a cassette. I don't know if you were able to see that video.
Yep.
So it's basically a cassette that pulls out, and they service the elevator from right there. Now, if the mechanic's working on it, what they would do is open the elevator door, and then they also have line of sight to that machine because it's right there in the overhead.
Okay.
So basically, we're taking all those components and we're putting them right there in the same spot instead of a controller, kind of down the hall. Well, that's pretty easy for questions, I guess. Like I said, if anybody has an architectural firm and you're interested in a presentation, I would be happy to set that up with you. But thank you for having me tonight, and hopefully I'll hear from some of you soon.
Thank you, Stephanie. Good presentation.
Thank you very much, Stephanie. It's all right. We appreciate your time. We appreciate your knowledge and the sharing of knowledge here. I'd like to thank everybody for joining us tonight. And then for those CSI members, and even if you're not a CSI member, I will promote that, we are always looking for people to join us, and we're going to be starting up our year closes out over the summer, and so we'll be looking to get some more people involved. We'll have openings for directors and also just on some committee positions if you're interested to give us a hand with some things. It's a good group of people. a lot of interesting things to learn along the way. All right, Stephanie, thank you very much.
Thank you.
Thanks all for joining us, and everybody be safe and take care.